Welcome to a world where mathematics meets magic. Vedic mathematics is the name given to the ancient system of Indian mathematics. The Vedas were not written down, but passed down from generation to generation through oral transmission. The Sanskrit word Veda is derived from the root word vid, meaning to know without limit. We still use vid in Vidyalaya, Vidya, almost in all languages in India. In 21st century, Vedic mathematics offers an organic solution. It helps us to make use of our mind, a vastly underutilized resource within us, and help us to traverse the journey from chaos to confidence. This video is on shortcut techniques involving multiplication. Let's start with some patterns in multiplication. So let's start with multiplication by 5. The idea is you have to get the answer orally. So 28 into 5. Now instead of 5, you can write 10 by 2. So essentially, this becomes 280 divided by 2. So you get the answer as 140. 42 into 5 becomes 420 divided by 2, which is 210. 89 into 5, 890 divided by 2. So you have 2 4s are 8, 2 4s are 8 and 5. 648 into 5. So put a 0 behind 648 and divide by 2. So you have 2 3s are 6, 2 2s are 4, 2 4s are 8. And the 0 comes into the picture. 1296 into 5. So again put a 0 behind 1296 and divide by 2. So you have 2 6s, 2 4s, 2 8s and the 0. Even if it is a large number, you just have to put a 0 and divide by 2. So you get 9, 3, 2, 1, 3, 0. Easy, right? You don't have to write a step and straight away you get the answer. Similarly, let's see multiplication by 11. So 24 into 11. Now when we multiply with 11, it is 10 plus 1, which effectively means 240 plus 24. And you get 264. So you don't have to write any step here. 24 into 11, you can start with 2, then add 2 plus 4, gives you 6, and then 4. Let's check another number, 42 into 11. So start with 4. What is 4 plus 2? 6 and 2. Now what if the number has a carry forward? So nothing, you just shift that carry forward to the neighbor. So here when I add 6 plus 5, I get 11. So that 1 gets carry forward. So my answer would be 7. 6 plus 1, 7. 1, 5. Right? So when I say 65 into 11, that is 650 plus 65, which gives you 715. So let's try another number. 79 into 11. Now, if you are observing, we are doing the calculation from left to right, which is easier when you do it mentally. So 7 and 9 gives you carry forward of 1. Right? So instead of 7, you will write 7 plus 1, 8. 9 plus 7 ends in 6 and 9. 87 into 11. Now, 7 plus 8 is 15. That is a carry forward of 1. So 8 will become 9, 5, 7. 98 into 11. Now, you know 9 plus 8 is 17, which gives a carry forward of 1 to 9. So that becomes 10. 9 plus 8 ends in 7 and 8. Let's continue with more multiplication methods. The idea is you have to do it mentally. So let's see some examples. If you have 14 into 12, you can easily do this as 14 plus this x is 2, which is 14 plus 2 gives you 16. And then multiply 4 into 2, 8. Let's try one more. So if you have 13 into 13, you have 13 plus 3 is 16 and 3 3s are 9. Now, if you're observing mentally when we solve, we are very comfortable doing from left to right. Ideally, we start from the decimal end and go towards the left. Moving on. 12 into 15. So you have 12 plus 5, which is 17. And 5 into 2 is 10. Now you don't write 10, you write 0 and 1 is carry forward. So you get the answer as 180. Let's try one more. 18 into 13. Now 18 plus 3 is 21. 3 eighths are. Right, 3 eighths are 24. You write 4 and 2 is carry forward. Hence, you get the answer as 234. Next one, 19 into 12. 19 plus 2 is 21 and 9 twos are 18. So, adding the carry forward, you get the answer as 228. 17 into 14, 17 plus 4, 21. 4 sevens are 28. So, you get the final answer as 238. Wasn't it interesting to do all these multiplications mentally? Now, these are really beautiful methods which are based on patterns and observation. Hi, I'm Shilpa, and in today's video, we'll discuss in detail the multiplication shortcut tricks and techniques. Now, we'll be discussing these two methods which are based on the sutras, which is taken from Vedic Mathematics. So, number one would be the Urdhav Triyak Bhyam, which is vertically and crosswise method, and the number two is Nikhilam Navdash Sharmam Dashata, which is all from 9 and last from 10. Based on this, you can do any multiplications orally without writing any steps. Modern maths is more left brain oriented, emphasizing logical and analytical thinking. However, in a rapidly changing world, interdisciplinary approach is the key. It makes sense to integrate Vedic mathematics along with modern mathematics and bring balance between both sides of the brain. Before we start with the multiplication methods, let's quickly go through the pointers. Try to avoid pen and paper. Approximation is way better than perfection. Just like in case of that multiplication of 11, follow left to right approach. It's perfectly okay to make mistakes. The whole idea is the methods are flexible, so be creative. It's okay to find your own methods. So let's discuss the multiplication methods. Broadly, we will be discussing the two methods through which you can calculate any digit multiplications. So the first is universal method and second is base method. Both are based on Vedic mathematics. Now the first method, which is universal method, Urdhav Triyak Bhyam, or popularly I'm going to call it as universal method for easy understanding, is one of the 16 sutras of Vedic mathematics. Now the meaning is vertically and crosswise. So Urdhav means vertical and Triyak Bhyam means crosswise. Now the best part about this method is any big numbers can easily be simplified as a multiplication of two-digit numbers and adding. So this method just doesn't only limits to two-digit. We can use this for three-digit, four-digit and all based on a very simple pattern. And there is no need to write any steps and you straight away get the final answer. The philosophy behind this sutra is to simplify a problem into a simpler version and try solving. So any heavy calculations can be simplified into easy parts and you easily get an answer. It is a beautiful method. The beauty of this method is when you keep solving these questions and all, you get a sense of perspective. So if there is a three-digit into a three-digit, you have an idea what kind of answer you get, the limit, the higher range and the smaller range. So let's see some examples and understand this method. So if you have a question which is 14 into 21, you can write 14 and below 14, just write 21. And the order is we start with 4 into 1, then cross multiply, which is 4 into 2 and 1 into 1 and add. And finally 2 into 1. So your answer will be 4 into 1 gives you 4. Now 4 2s are 8. 8 plus 1 gives you 9. And finally 2 1s are 2. Now see, there was no step involved in getting this answer. Right. And had it been your conventional method, you would have done 14 into 21, as you started with 1 and you write 14. Then 2 4s are 8, 2 1s are 2, and you get an answer after writing 3 steps. So with this vertically and crosswise, you straight away get the final answer. You don't have to go through the processes. Let's try another example. 41 into 32. Now try to do this on your own. You remember, right? You write 41 and below 41 write 32. The order is 2 into 1 followed by 2 into 4 plus 3 into 1 followed by vertical, which is 4 into 3. And your answer would be 2 1s are 2. Then 4 2s are 8. 8 plus 3 is 11. You can only write 1. The other one gets carry forward. And 4 3s are 12. 12 plus a carry forward gives you 13. So remember, you're only allowed to write the single digit. So everything else get added to the neighbor. Now let's try another question and try to get the answer. 53 into 64. The process is 53, 64. You start with 3 into 4. You are only allowed to write a single digit. Everything else goes carry forward. Cross multiply is 5 into 4 plus 6 into 3 followed by 6 into 5. So 3 4s are 12. You are allowed to write 2. 1 is carry forward. Now 5 4s are 20. 6 3s are 18. You get 38. Add the carry forward. You get 39. So you will write 9 and 3 is again carry forward. Finally 5 into 6 30. 30 plus 3. You get the answer as 3392. Easy, right? Okay, now let's try to generalize. If you have 2-digit number AB into CD, you start with B into D, followed by AD plus BC, and finally A into C. Remember, single digit here, single digit here. No steps. This is one of the beautiful way of multiplying any 2-digit number. Moving on to the next method, which is base method. Nikhilam navtascharamam dashatah, which means all from 9 and last from 10. This is one of the 16 sutras in Vedic mathematics. I'm going to call this as base method. Now, this method is really useful when the two numbers are closer to a base. Now, the base could be 10, 100, 1000, 10,000. So the beauty of this method is, for example, if I give you 103 into 108, you easily get the answer with a left to right approach. 103 plus 103 plus 8 is 111. 3 8s are 24. So your answer is 11124. Now, if it is a 2-digit number, for example, 14 into 12, your answer is 14 plus 2, 16. 4 2s are 8. So you get 168. Or if it is 1008 into 1003. Now the base is 1000, so you have 3 places of decimal at the end. So you have 1008 plus 3 is 1011 followed by 0 to 4. So you can see this can easily help you to get any of this kind of multiplication. Try some questions. So let's start with a number 103 into 106. Now both the numbers are closer to the base 100. And how far is 103 from 100? 3 units, and 106 is 6 units. So what you do in this method is you multiply this excess. 6 into 3 gives you 18. And finally, either add 106 plus 3 or 103 plus 6. So you get 109. Easy, right? Try this similar question. 108 into 104, the surplus is 8 and 4. So what you do is you multiply 4 into 8. You get 32. Either add 104 to 8 or 108 to 4. You get 112. Really easy way, right? No need to write any steps. And it's kind of symmetrical. Now, what if both the numbers are deficit, that is less than your base? For example, 93 into 92. One is minus 7 deficit and the other one is minus 8 deficit. So again, the same thought process, minus 7 into minus 8 gives you plus 56. Either subtract 92 with 7 or 93 minus 8. So you get 95. Your answer is 9556. Now try this question on your own. 91 into 96. So 4 9s are 36. 96 minus 9 or 91 minus 4 gives you 97. Correct. Now, the base need not only be 100, it could be 10, it could be 1000, right? And this method is when both the numbers are closer to the base. Now, let's try a different base. Okay, when we have 103 into 96. Now, this is base 100, but one is more than 100, the other is less than 100. So what do we do? So the same thought process, 3 and minus 4. My only problem is you get minus 12 when you multiply. And 96 plus 3 or 103 minus 4 gives you 99. So what is your final answer? You cannot have a minus in your answer, no? So your final answer will be 9900 minus 12. So your final answer will be 9888. Right? So minus 12, there was a deficit. When you had excess, you gave it to the neighbor. So when you have a deficit, you borrow from the neighbor. So you borrow from 9, right? And you get the answer as 9888. Now try this method on your own over here. 108 and into 99. You can pause the video, solve it and check your answer. So 108 is plus 8 and 99 is minus 1. So 8 into 1. Now base is 100. So you have to have 2 digits here. So you don't write 8, you write minus 8. Base is 100. So you have 2 places of decimal here. 108 minus 1 or 99 plus 8. Either ways, you get 107. Now remember, what will be your final answer? 10700 minus 08. So you get 10692. So your final answer is 10692. Right. So it need not be that both the numbers are more than 100 or both the numbers are less than 100. It could be one is more and one is less. Only thing you have to take care is if there is a negative, you have to borrow from the neighbor and get the final answer. Now let's try a different base. Now this is an easier base, I suppose. So try these questions. And the whole idea is you're supposed to do it orally. So 14 into 12, the base is 10. So the same process, 4 into 2 gives you 8. Now base is 10, so you're only allowed to write one digit here. 12 plus 4 or 14 plus 4 gives you 16. 18 into 14. So 4 into 8 is 32. You will write only 2. 3 is carry forward because the base is 10. You have only one digit here. 18 plus 4 or 14 plus 8 is 22 plus carry forward of 3. So 22 plus 3, you get 252. 9 into 8, I know you already know the answer, but you can just check this method. It's so beautiful. 9, the deficit is minus 1. 8, it's minus 2. So 2 ones are 2. So either 8 minus 1 or 9 minus 2, which gives you 7. 12 into 8, you know it's 96. But let's try this method. 2 into 2, which is minus 4. Either you do 12 minus 2 or 8 plus 10. 8 plus 2, which is 10. Remember, you need to subtract. So you get 96. Let's go through some miscellaneous multiplications. Remember, in the beginning, we have seen multiplication by 11. So 63 into 11 will be 6. 6 plus 3, 9, followed by 3. 86 into 11, remember that carry forward. So 8 plus 1, it becomes 9. 9 plus 8, 8 plus 6, 14, and followed by 6. So 123 into 11. Now, what if it is 3-digit numbers? So what you do is you start from 3 and then keep adding 2 digits at a time. So 3 plus 2, 5. Then 2 plus 1, 3. And finally you write 1. Which is again when I ask you 123 into 11 is 1230 plus 123. Which gives you the answer as 1353. Yeah. Let's try another one. 2314 into 11. So start with 4. Then keep adding 2 digits at a time. 4 plus 1, 5. 3 plus 1, 4. 3 plus 2, 5. And finally, you write 2. So this is your answer. Why don't you try the next one? 4372 into 11. So 2, 7 plus 2, 9, 3 plus 7, 10. There is a carry forward which goes to the neighbor. 4 plus 3, 7, 7 plus 1, 8, and you write that 4. Okay? Now, how about this, the last one? So, you start with 4, then 4 plus 2, 6, 5 plus 2, 7, 5 plus 3, 8, 3 plus 1, 4, 2 plus 1, 3, followed by 2. Okay, so adding 2 digits at a time and keep moving towards left. Now let's see some pattern. 1 square is 1, 11 square is 121, 111 square is 12321. So what if I ask you 111, 41 square? Yeah, so of course you will go till 4 and then come back to 1. Interesting pattern, right? So in case of 11, we were adding two numbers at a time. So what if I give you a multiplication by 111? Right. So in this case, you will start with 1 number, then you add 2 number, and then you take pairs of 3 numbers. Then finally to 1. Right. Let's see this pattern. So you start with 4, and then you add 2 numbers at a time. 4 plus 1, 5. Then you will take all 3 numbers together. 4 plus 1, 5. 5 plus 2, 7. Then you take 2 numbers at a time. 2 plus 1, 3. And finally, you will write that number. So remember, 111 square was 1, 2, 3, 2, 1. So we started with writing 4. Then we added 2 numbers at a time. Then we took all 3 numbers at a time. Then 2 numbers at a time, and then the single number. How about you try this question? So first, you start with the single number 2. Then you add 2 numbers at a time. 4 plus 2, 6. Then you take all 3 numbers together. 3 plus 4, 7. 7 plus 2, 9. Now, are you done with all the 3 pairs? No. If I keep moving, 1 left. I have 2, 3, 4. Another pair of 3 numbers. So 3 plus 2, 5. 5 plus 4, 9. I'm done with all 3 pairs. I'll move to 2 pairs, which is 2 into 3. So 2 plus 3, 5. And finally, that single digit, 2. So last one, try getting the answer. You start with 5, then take 2 numbers at a time, which is 8. Then take all 3. 5 plus 5, 10. You'll write 0. 1 is carry forward. Move to the next pair of 3. 6 plus 2, 8. 8 plus 3, 11. 11 with a carry forward 1 becomes 12. You write 2, 1 carry forward. Now you're done with all 3 numbers. You move to 2. 6 plus 2, 8. 8 plus 1, 9. And finally, you write 6. Of course, with 111, you have to have that patience. But if you see the pattern, it's really easy. Now, try the last one. 8, 7, 1, 2, 3 into 11. So you start with the first number, 3 you write as such. Then you add 2 numbers, 3 plus 2, 5. Then you take all 3 together. 3 plus 2, 5. 5 plus 1, 6. Move to the next pair of 3. 7 plus 1, 8. 8 plus 2, 10. You write 0, 1 carry forward. Move to the next pair of 3, which is 8, 7, 1. 15 plus 1, 16. 16 plus 1, 17. You're done with all the pair of 3. You move to 7 plus 8, 15. 15 plus 1, 16. And then you write the single number 8, but there's a carry forward, because of which you get the answer as 9670653. Let's reiterate quickly. So in this video, we discussed 2 methods for multiplication. Number 1, Urdhva, Triyak Bhyam, which I referred as universal method. Universal method because it is applicable for any numbers. There is no limitation. And Urdhva Triyak Bhyam, the meaning is vertically and crosswise. And this method actually helps you to do any large calculations. It can be broken into simple multiplication and addition. The next method was Nikhilam Navtasharmam Dashata, all from 9 and last from 10, which I referred as a base method. any numbers which are closer to base, this can be easily used. A beautiful method where you can easily get the answer. Between the two methods, you can use the universal method for any numbers. But the next method, which is Nikhilam Navta Charmam Dashata, only when the numbers are closer to the base. Hope you enjoy doing this multiplication, but the very important thing for this multiplication is that you need to continuously practice. And yes, there's this beautiful app which we have, right? Our brain. So the whole idea would be you need to utilize the brain. You need to set it to practice. The more you practice, the better grasp you will have. So it's time to actually say our gratitude to our ancient Indian mathematicians who had discovered such beautiful methods. So these are fluid ways of doing mathematics rather than following a set fixed approach of step by step. In all these methods, if you have noticed, we are concentrating on the final solution instead of the machineries. And in the method where we are using the base method, you are taking the excesses and surplus. This is something like you're taking the alter ego of the number and then doing the processes. So in a way, it is talking about a philosophy of life. And in both the methods, the best underlying factor would be the perspective. You have a very clear idea about the kind of answer you're getting with this method. Professor Manjul Bhargava. He's an Indian origin mathematician who won the Field Award in 2014. Inspired by the timeless wisdom of ancient Indian mathematician, Professor Manjul Bhargava rightly says India holds within its heritage a treasure trove of mathematical brilliance. India has to be its own cultural ambassador. It's time to bring alive all those ancient Indian work, which is yet not known to the public. Only one thing is really important, that it has to be done in a scientific manner. And these methods are so beautiful that the classes has to become more engaging. Let's ensure that mathematics is fun. That's all for the video today. Do ensure you subscribe to this channel for more such classes. Thank you.